Hello friends, you have learned in your previous classes how science plays an important role in our day-to-day life. This is class 11th. Now we are entering in the world of chemistry. At this stage, let us emphasize more on experiments, technology and investigatory projects. Have you ever wondered how curd is formed from milk, how medicines cure diseases, or how rusting of iron takes place? Answer of all these and similar type of questions is one word: chemistry. Chemistry is the branch of science that studies the preparation, properties, structure, and reactions of material substances. Dear children, in ancient India, chemistry was called Rasayan Shastra, Ras Tantra, Ras Kriya, or Ras Vidya. It included metallurgy, medicines, manufacture of cosmetics, glass, dyes, etc. India had its own alchemical traditions. Copper utensils, iron, gold, silver ornaments, and painted grey pottery have been found in many archaeological sites in India. Children, chemistry is interlinked with branches of sciences and plays a central role in science. Let us explore how chemistry is important in our daily life. Identifying the weather patterns, functioning of brain, operation of a computer, production in chemical industries, manufacturing fertilizers, manufacturing alkalis, acids, salts, dyes, polymers, and dear children, drugs, soaps, detergents, metals, alloys, including new material, all is chemistry. Chemistry contributes in a big way to the national economy. Chemistry has helped in establishing industries which manufacture utility goods like acids, alkalis, dyes, polymers, metals. These industries contribute in a big way to the economy of a nation and generate employment. Friends, in recent years, chemistry has helped in solving many environmental problems like management of the greenhouse gases, pollution. These issues are the challenge for chemists. A developing country like India needs talented and creative chemists for accepting such challenges. To be a good chemist and to accept such challenges, one needs to understand the basic concept of chemistry, which begin with the concept of matter. In order to understand the application of chemistry in different fields and benefit from it, it is important that we know what is matter. You are already familiar with the term matter from your earlier classes. Anything which has mass and occupies a space is called matter. Matter usually exists in three physical states like solid, liquid, and gases. Particles are held very close to each other in solids. In liquids, the particles are close to each other but they can move around. However, in gases, the particles are far apart as compared to those of solids and liquid states. These three states of matter are interconvertible by changing the conditions of temperature and pressure. The solids can be directly converted into gases by the process of sublimation. This you all have studied in the class 9th. Now let's have a quick quiz about this. Children, on the basis of various characteristics like volume, shape, intermolecular distance, movement of particles, you have to compare solids, liquids and gases in the tabular form. Friends, on the basis of chemical composition, matter can be classified as mixture or pure substances. When all constituent particles of a substance are same in a chemical nature, it is said to be a pure substance. A mixture contains particles of two or more pure substances which may be present in it in any ratio. A mixture may be homogeneous and heterogeneous. You all have studied about homogeneous mixtures and heterogeneous mixtures in the class 9th, and you will study it in detail in class 12th. Pure substances can further be classified into elements and compounds. Particles of an element consist of only one type of atoms. These particles may exist as atoms or molecules. Friends, sodium, copper, silver, hydrogen, all these are examples of elements. Their all atoms are of only one type. You may be familiar with atoms and molecules from the previous classes. When two or more atoms of different elements combine together in a definite ratio, the molecule of a compound is obtained. Some compounds such as water, ammonia, carbon dioxide, sugar, glucose, and many more you all know. Just make a table and try to identify the difference between elements and compounds. Every substance has a unique or characteristic properties. These properties can be classified into two categories: physical properties such as color, odor, melting point, boiling point, density, and chemical properties like composition, combustibility, reactivity with acids and bases. Physical properties can be measured or observed without changing the identity or the composition of the substance. The measurement or observation of chemical properties requires a chemical change to occur. Now we will learn about the measurement of physical properties. Earlier, two different systems of measurements, that is, the English system and the metric systems, were being used in the different parts of the world. Nowadays, we follow a common standard system of measurement, that is, the International System of Units. The SI system has 7 base units. Now children, please look to the screen and see what are these basic units. The basic unit of length is meter. The basic unit of mass is kilogram. And now you can see there are so many further units which you will use in your coming chapters. The SI system allows the use of prefixes to indicate the multiples or submultiples of a unit. Now please see the table. Deci is used for 10 raised to the power of minus 1. Centi is used for 10 raised to the power of minus 2. Milli is used for 10 raised to the power of minus 3. In the same manner, micro for 10 raised to the power of minus 6 and nano for 10 raised to the power of minus 9. Let us now quickly go through some of the quantities which we are going to use in the coming chapters. The mass of a substance is constant, whereas its weight may vary from one place to another. Friends, do you know why? Yes, because of the change in gravity. The SI unit of mass is kilogram. However, its fraction named as gram. 1 kilogram is equal to 1000 gram. It is used in the laboratories because of the smaller amounts of chemicals which we use in chemical reactions. Volume. Volume is the amount of space occupied by a substance. It has the units of length raised to the power of 3. So in SI system, volume has units of meter cube. But again, in chemistry, in laboratories, we use smaller volumes. Here, volume is often denoted in centimeter cube or decimeter cube. A common unit, liter, which is not a SI unit, is used for the measurement of volumes of liquid. 1 liter is equal to 1000 milliliter and 1000 centimeter cube is equal to 1 decimeter cube. Friends, remember, this is very important units which you are going to use in coming chapters. Density. Density is equal to mass per unit volume. The SI unit of density is kg per meter cube, but we are going to use the unit gram per centimeter cube because in laboratories we use smaller quantities of substances. There are 3 common scales to measure temperature. First one, degree Celsius, second, degree Fahrenheit, and third one, Kelvin. Kelvin is the SI unit. The temperatures on 2 scales are related to each other by the following relationship. C by 5 is equal to F minus 32 by 9. The Kelvin scale is related to Celsius scale as follows. Kelvin is equal to degree Celsius plus 273.15. Children, note that temperature below 0 degree Celsius, that is negative values, are possible in Celsius scale, but in Kelvin scale, negative temperature is not possible. Friends, let us do some conversions. You can see on the screen how 1 kilometer is converted into millimeter. 1 kilometer is equal to 10 raised to the power of 6 millimeter. And how you can convert this millimeter into picometer? Just using the table which we have learned earlier. 10 raised to the power of 6 millimeter is equal to 10 raised to the power of 15 picometer. 1 milligram is equal to how many kilogram? Just try to find out. It is 1 milligram is equal to 10 raised to the power of minus 6 kilogram, and it is equal to 10 raised to the power of 6 nanogram. Now we are going to convert the milliliter into liters. 1 milliliter is equal to 10 raised to the power of minus 3 liter, and it is equal to 10 raised to the power of minus 3 decimeter cube. Friends, let us see how much we have learned till now. Now you can see on the screen, the first question is, if the speed of the light is 3 into 10 raised to the power of 8 meter per second, calculate the distance covered by light in 2 nanoseconds. Friends, I want to give a hint here. Here you can see the time is given in nanosecond. First of all, you will convert it into SI unit, and then you will use that in calculation of the distance. In the second question, convert the following into basic units. 28.7 picometer, 15.15 picometer and 25365 milligram into its basic units. Do you know how much we have learned till now? You will be able to appreciate the importance of chemistry in our daily life. Appreciate the contribution of ancient chemistry of India and its role in different spheres of life such as medicines, pottery, dyes. You will be able to explain the characteristics of matter. You will be able to convert one form of unit into another and use SI base units and some commonly used prefixes. Friends, we have learned that chemistry deals with matter, and matter is made up of atoms and molecules which have extremely low masses and are present in large numbers. So chemists have to deal with not only with the large number of atoms and molecules, but also with the calculations containing large numbers. We are going to learn about the scientific notation so we can do the calculation easily. For example, Avogadro numbers contain 20 zeros after 6022. Similarly, other constants such as Planck's constant, speed of light, charges on the particles, etc. involve numbers of the above magnitude. It may look funny for a moment to write or count number involving so many zeros, but it offers a real challenge to do simple mathematical operations of addition, subtraction, multiplication, or division with such numbers. This problem can be solved using scientific notation, which is also known as exponential notation. In scientific notation, any number can be represented in the form of n into 10 raised to the power of n. On the screen, you can see how we can write scientific notation. Here, in n into 10 raised to the power of n, lowercase n is an exponent having positive or negative values, and uppercase n is a number called digit term which can vary between 1 and 10. For example, we can write 232.508 as 2.32508 into 10 raised to the power of 2 in scientific notation. Similarly, for writing 0.00016 in scientific notation, we will use 1.6 into 10 raised to the power of minus 4. Now let's see how to perform mathematical operations on numbers written in scientific notation. Let's start with addition and subtraction. The numbers we have to add or subtract written in scientific notation, we must first check if the exponent of the number is the same. Only if they are same, then we can add or subtract the coefficients. For example, in this equation, 6.65 into 10 raised to the power of 4 plus 8.95 into 10 raised to the power of 3. One exponent is 4 and the other is 3. Therefore, in order to add the numbers, we have to make exponents same. As 6.65 has the larger exponent 4, we have to convert the exponent 3 to match the larger exponent. So we rewrite the 8.95 multiplied by 10 raised to the power of 3 as 0.895 multiplied by 10 raised to the power of 4. Now, after taking the exponential factor in common, we add both the coefficients and get the result 7.545 multiplied by 10 raised to the power of 4. Now you can see on the screen how we have obtained the result. Same rule applies to the subtraction. For the multiplication, we add the exponents and multiply the coefficients. For the division, we subtract the exponents and divide the coefficients. Children, now it's a quiz time. Let us perform the following mathematical operations on numbers expressed in scientific notations. Now, as you can see on the screen, the question number 1 is 5.6 multiplied by 10 raised to the power of 5 multiplied by 6.9 multiplied by 10 raised to the power of 8. Second question, 2.7 into 10 raised to the power of minus 3 divided by 5.5 into 10 raised to the power of 4. Third question, 2.5 multiplied by 10 raised to the power of minus 2 minus 4.8 into 10 raised to the power of minus 3. Children, when performing experiments, we often perform mathematical calculation to obtain accurate results. People often use the word precision and accuracy interchangeably. But are accuracy and precision the same? Let's see. For example, 3 students are performing an experiment. In this, the correct result is 2 gram. The student A takes 2 measurements and reports the result 1.95 gram and 1.93 gram. These values are precise as they are close to each other, but they are not accurate. Another student, B, repeats the same experiment and obtains 1.94 gram and 2.05 gram. As the results for 2 measurements, these observations are neither precise nor accurate. When the third student, C, repeats these experiments and reports 2.01 gram and 1.99 gram as the result, these values are both precise and accurate. You can see on the screen how these measurements are compared among the student A, B and C. Hence, we can say that precision refers to the closeness of various measurements for the quantity. However, accuracy is the agreement of a particular value to the true value of the result. Always remember, accuracy without precision can be a matter of chance. Friends, the certainty and uncertainty in a measurement is indicated through significant figures. For example, mass of an object is obtained using a platform balance and it comes out to be 9.4 gram. On measuring the mass of this object on an analytical balance, the mass obtained is 9.4213 gram. Significant figures are meaningful digits which are known with certainty, plus one which is estimated or uncertain. The uncertainty is indicated by writing the certain digits and the last digit uncertain. Thus, if we write a result 11.2 milliliter, we say that 11 is certain and 2 is uncertain, and the uncertainty would be plus 1 in the last digit. Children, now we will learn certain rules for determining the number of significant figures. As you can see on the screen, first rule says that all non-zero digits are significant. For example, in 285 centimeter, there are 3 significant figures, and in 0.25 milliliter, there are 2 significant figures. According to the second rule, 0 preceding to first non-zero digits are not significant. Such 0 indicates the position of decimal point. Thus, 0.03 has one significant figure and 0.0052 has two significant figures. The third rule is zeros between two non-zero digits are significant. So, 2.005 has four significant figures. The fourth rule says that zeros at the end or right of a number are significant, provided they are on the right side of the decimal point. For example, 0.200 gram has three significant figures. However, the terminal zeros are not significant if there is no decimal point. For example, 100 has only one significant figure, but 100 point has three significant figures and 100.0 has four significant figures. The fifth rule says that the exact numbers obtained by counting the numbers of the object have infinite significant figures. For example, 2 balls or 20 eggs have infinite significant figures, as 2 and 20 are exact numbers and can be represented by writing the infinite number of zeros after placing a decimal, like 2.000 or 220.0000 infinitive. Friends, let's see how to determine the significant figures in the result of mathematical operations. While doing addition and subtraction, the result cannot have more digits to the right of the decimal point than the either of the original numbers. While doing the addition of 12.11, 18.0 and 1.012, we get the result 31.122. Here, 18.0 has only one digit after the decimal point. So, the result should be reported only up to one digit after the decimal point, which is 31.1. While doing the multiplication and division, the result must be reported with no more significant figures as in the measurement with the few significant figures. For example, 2.5 when multiplied by 1.25, we get the result 3.125. Since 2.5 has two significant figures, the result should not have more than two significant figures. So it should be 3.1. Now let us look the rule for rounding of the numbers. According to the first rule, if the rightmost digit is to be removed is more than 5, the preceding number is increased by 1. For example, 1.386, if we have to remove 6, we have to round it up to 1.39. The second rule, if the rightmost digit to be removed is less than 5, the preceding number is not changed. For example, 4.334, if 4 is to be removed, the result is rounded up to 4.33. The third rule, if the rightmost digit to be removed is 5, then the preceding number is not changed if it is an even number, but it is increased by 1 if it is an odd number. For example, if 6.35 is to be rounded by removing 5, we have to increase 3 to 4, giving 6.4 as the result. However, if 6.25 is to be rounded off, it is rounded off up to 6.2. Children, when we perform mathematical calculations, we need to convert units from one system to another. This can be done by a method called factor label method or unit factor method or dimensional analysis. Let us understand this through an example. Assume that we have to convert the length of a piece of a metal from 3 inches to centimeter. We know that 1 inch is equal to 2.54 centimeter. 3 inches will be equal to 3 multiplied by 2.54 centimeter, which will be equal to 7.62 centimeter. Friends, try to do more conversions which are given in your book. Now let us do few conversions which I have shown on the screen. Friends, express the following in the scientific notation. 0.0048, 234.000, 8008, 500.0, 6.0012. Now you can see on the screen the second question. It is, how many significant figures are present in the following? A. 0.0025, B. 208, C. 5005, D. 126.000, and the last one is 500.0. Now children, let us see how much we have learned till now. Now you will be able to use scientific notations and perform mathematical operations on numbers. You can differentiate between precision and accuracy. You will be able to determine significant figures. Children, now try to solve more and more problems from the chapters. Whenever you are doing the numericals, try to convert the answer into scientific notation, because this will help you. Children, I have seen that while performing the numericals and doing calculation, children do not convert one unit into another and add kilometer into meters. So, try to avoid these types of mistakes. For better learning, for better understanding, do more problems. Thank you. Happy learning.